Hello friends, in this session we'll try to understand some basic concepts of programmable logic controller, which is generally known as PLC. So PLC contains mainly six components, which are central processing unit, power supply, input module, output module, memory, which is used to store system memory and program memory, and programming devices. Let's try to understand PLC architecture. We can see the main part or brain of the system is central processing unit, which is supplied by power supply, an input module which acts as the interface between the inputs, which comes from various sensors like push buttons, contacts, limit switches, or various electronic sensors, and it is fed to the CPU. An output module which acts as the interface between CPU and the output devices such as solenoid, coils, contacts, alarms, etc. Input module and output modules both are separated electrically using optoisolators to protect any kind of short circuit or any electrical hazards. A programming device is used to program the PLCs. There are many programming devices. Memory is used to store program memory as well as data also. Program memory is the part where the boot program of the system is stored, which acts as the ROM, and data memory where the executable program or the application programs are stored. Now, here is the first reflections question. Can you name some programming devices that can be used for PLC programming? There are many, and I'm sure you can think of something. So let's take a pause and try to think over this question. Alright, so various PLC programming devices are like handheld programming devices such as tablets, industrial programming panels which are used in industries, and personal computers which are very popular and easy method of programming the PLCs. Let's try to understand the PLC scan cycle. Once the PLC is turned on, it does internal processing. Over here, it checks the status of each of its peripherals. Then it reads input from the input module and execute the program. And if there is any problem or any mistake in the program, that is diagnosed in diagnostic cycle. And after that, the outputs status are updated. This process gets continued until the complete program of the PLC or complete process is executed. Let's try to understand how we program the PLCs. As PLC is logic controller, so two logics are implemented to program the PLCs, which are known as normally open and normally closed. In normally open logic, when the logic is high or the input is 1, then the circuit is connected and the supply is given to the next stage or the output. In case of normally closed, it is by default connected, and when the logic is 1, it gets disconnected and circuit is break and there is no output to the next stage. The outputs in PLC programming are represented by the coils. The coil represents relays that are energized when power flows to them. Some part of these outputs or coils can also be used as the control inputs anywhere in the program also. That can be seen in further or modified or advanced programming. Let's try to understand the PLC programming. The very popular method of PLC programming is using ladder diagram. In ladder diagram, we can see there are some components which has specific terminologies like rung and two vertical lines, left line acting as the live wire and right vertical line acting as the neutral. Inputs are placed generally to the left hand side of the rung and outputs are placed generally to the right hand side of the rung. Each rung or network on a ladder program represents a logic operation. So let's try to understand or implement some basic logic gates using PLC's ladder diagram approach. So the basic logic gates are like NOT gate, AND gate and OR gate. Let's start with the AND gate operation. In case of AND gate, we know that when we have both the inputs high or both the inputs 1, then only we get the output, otherwise not. That we can verify using this truth table. And in case of ladder diagram approach, we can see that both the logics or both the inputs A and B are represented in terms of normally open contact. So whenever logic 1 is applied over here, this connection will be connected. Similarly, logic 1 to the contact B, so this connection will be made or it will be connected. When both the connections are made or connected, then the supplies goes to the output and we get the output. On similar lines, we can also understand the operation of OR gate. In case of OR gate, from the truth table we can see that if any of the input in OR gate is logic high or 1, then we can get the output. The only case we don't get the output is when both the inputs are 0 or logic low. This we can verify using ladder diagram. We can see that when logic 1 is applied to the contact A, we get the output, or when the logic B is also applied as logic 1, then also we get the output. Why? If any of these or both of these are at logic high or logic 1, then we'll get the output. The only case we don't get the output is if none of these are provided with logic high. It means when both are logic 0, then there is no output at all. Having understood the operation and implementation of AND and OR operation, let's have the next reflection question. Can you think of implementation of NOT gate using ladder diagram? Just think for it, try to draw, try to implement it. You can take a pause and solve the problem. Alright, let's try to understand, which is very simple. As we know that in case of NOT gate, only two conditions are there. When the logic is 1, this circuit is normally closed, it will get braked and there is no output to this contact and output will be 0. So we'll not get basically any output. And when the logic is 0 or when nothing is applied, so this connection being normally closed will by default be closed and there will always be an output and we'll get the output as 1. This can be verified using truth table also. So friends, we try to understand basic components, architectures of PLCs, its way of programming using ladder diagram, some basic logic gates implementations using ladder diagram of PLCs. I hope you understood this session. Thank you so much.